So in this video for 6.2 notes, we're going to talk about finding probabilities with normal distribution and talk about how you can actually use the same rules as before with adding and subtracting variables to find means and standard deviations just as normal random variables. So the same rules will apply here. And for this, we're going to do an example from the book, page 385, number 62. So please have your book in front of you as we do this problem. It makes it a lot easier to follow along. So to read this out loud, Ken is traveling for his business. He has a new 0.85 ounce tube of toothpaste that's supposed to last him the whole trip. The amount of toothpaste Ken squeezes out of the tube each time he brushes varies according to the normal distribution with a mean of 0.13 ounces and a standard deviation of 0.02 ounces. If Ken brushes his teeth 6 times on a randomly selected trip, what's the probability that he'll use all the toothpaste in the tube? So we're talking about a tube that's 0.85 ounces. A single squeeze has a mean of 0.13 ounces and a standard deviation of 0.02 ounces. So that's the mean and standard deviation for just a single squeeze of the tube. On this trip, he's doing 6 total squeezes, and they want to find the probability that he'll use more than what's in the actual tube, 0.85. So what you're finding is the probability that we'll call this variable t, the total amount, is greater than 0.85. Okay. Because it's normally distributed, we're allowed to use table A. This says in the book. And if we're going to use table A, we need to convert this to a z-score. Okay, so z-score for t is going to be 0.85 minus mu t divided by sigma t. You may incorrectly think that these two could go here, but the problem is this is for a single squeeze. This is total of 6 squeezes of the tube, okay? So we have to go ahead and find these two before we find the z-score. So the relationship that we found from the problem was 6 x values essentially added together. So we need to find mu t and sigma t. Well, if you have adding across your random variables, to find the the mean of the sum all the means. So it's mu x1, mu x2, I'm just going to put some dots in there, all the way up to 6. So there's going to be 6 terms here. Now each term is exactly the same as far as the mean goes. It's 0.13, 0.13, 0.13, 0.13, 6 times. So mu t is going to be 6 times 0.13. It's repeated addition and multiplication. This ends up being a mean of t of 0.78. So in our z-score formula, we have found that our term. Now we need to move on to find sigma t. So for random variables, to find standard deviation, you have to work through the variance. And as we talked about before, when you sum the random variables, like here, you actually can just sum the variances as well. So here's what it look like. Sigma t squared is going to be sigma x1 squared plus sigma x2 squared all the way up to sigma x6 squared. And they're all exactly the same. Sigma t squared is going to be equal to 6 times 0.02 squared. Because each one of these is 0.02 squared. There are 6 of them, so I do 6 times 0.02 squared. And when you do that, you get sigma t squared is equal to 0.0024. And to find the standard deviation, square root both sides. Sigma t is equal to 0.049. So we now have the mean of the total and the sigma standard deviation of the total. So what we're going to do is now plug in those two numbers. 0.85 minus 0.13, sorry, not 0.8, 0.78 divided by 0.049. And when you find that z-score, what you end up getting is 1.43. Now we can use this number in table A to find the proportion. And when you do that, you get 0.92 9236, I do believe. 9236. So the probability of t is greater than 0.85. You do the complement of this because this is less than. Table A always is less than 1 minus 0.9236. And what you get is 0.0764. Or you can write it as a percentage. There's a 7.64% chance that Ken uses all the toothpaste in his tube. Now, albeit this problem is absurd, it's a ridiculous situation to talk about because Ken could just obviously go buy a new tube of toothpaste if he finds out, and who really cares about the probability of it happening? But the idea is to focus on combining the variables, finding means, and standard deviations, and this contrived problem helps out with that. So, when you're approaching this problem, don't always assume that these two plug into the z-score formula. If it's a combination total or difference, depending on what the equation is, you have to make those adjustments with your equations for mean, standard deviation, and variance. This right here was not given to us in the problem. You have to be able to figure that out from a sentence or two of the situation. So we created it on our own. You should be able to do the exact same. From here, you need to be able to create the equation for the total, for the mean of the total, and the equation for the variance of the total. These two are also a skill you need to have. From there, it's just plugging in numbers and repeating those numbers up here for the z-score formula. And the rest of this is chapter 3 and 6.1. You've already done table A frequently. So this is all the old material. The prep work is what's new. Okay.